Okay, so we're going to talk about how to find a vertical asymptote if you're given a function. So vertical asymptotes will occur at points, or really just x values, where the denominator equals 0, but the numerator doesn't. So this is important because denominator equals 0, those are domain restrictions, but not all domain restrictions will be vertical asymptotes. The only ones that will be vertical asymptotes are where the bottom is 0, but the top isn't. So looking at our first example, if we're given this rational function, so we've got a polynomial on top, a polynomial on the bottom. If we're trying to identify the vertical asymptotes, we'd have to find where the denominator equals 0. So the easiest way to find the zeros of a quadratic is to factor it. So this is factorable. Factors into x minus 5 times x plus 2. And if we set it equal to 0, we get two values. So x equals 5 would be a discontinuity. However, the numerator equals 0 there, so it is not a vertical asymptote. X equals negative 2 is where the denominator equals 0 and the top does not equal 0. So this would actually be the only vertical asymptote. If you were stating the domain, though, you would still say all reals not equal to 5 and negative 2. But 5 would not be a vertical asymptote. It would have a different shape in the graph. And we'll talk about what it would do in the graph. X equals negative 2 will be the vertical asymptote. To find the horizontal asymptotes, it's a little trickier. So we have to look at the degrees of the polynomial on the top and the bottom. So the first rule, if the degree of the denominator is bigger than the degree of the numerator, then the line y equals 0 will be the horizontal asymptote. So it doesn't matter how much bigger the degree of the bottom is. If the degree of the bottom is bigger than the degree of the top by any amount, then y equals 0 is the horizontal asymptote, which is the x-axis, which is why we see that a lot when we graph rational functions, that the x-axis is a horizontal asymptote. The next rule is if the degrees are equal. So if the degree of the denominator is equal to the degree of the numerator, then the horizontal asymptote will be y equals a over b. And a and b are the leading coefficients of the numerator and the denominator. Okay, so a is the leading coefficient of the numerator, b is the leading coefficient of the denominator. And leading coefficients are the coefficients of the highest degree term. And since the degrees are equal, if you have a cubic over a cubic, then we take the leading coefficient of the top over the bottom. And then the third rule is if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. There's a special case where there could be what we call a slant asymptote, but that's not something we're going to get into today. We'll just say that there is no horizontal asymptote if this happens. So for the first example that we're going to go through, here we go. So f of x is 3x plus 2 over x squared plus 5x plus 6. So these questions are asking us to find the domain, asymptotes, that means vertical and horizontal, and then it also asks for the intercepts, which is something we didn't talk about, but that's something that we've done before with functions, so we can talk about it now. So domain, first thing we're going to do is look at the denominator and say that the zeros of the denominator, will not be in our domain. So if we factor the bottom would factor into x plus 3 times x plus 2. So our domain, we can write it as all real numbers not equal to negative 3 and negative 2. And if you wanted to do interval notation, you could say negative infinity to negative 3, negative 3 to negative 2, negative 2 to infinity. Soft brackets. All right, you'd have to have soft brackets around it, but this is a perfectly acceptable way of writing it. The next thing is to find the asymptotes. So the vertical asymptotes are the easiest to find since we already found the domain restrictions. Both of these will actually be vertical asymptotes because that's where the bottom equals 0 and the top does not equal 0 at either one of these. So the vertical asymptotes, their equations would be x equals negative 3 and x equals negative 2. The horizontal asymptote is we'd have to look at the degree of the top and bottom. The degree of the top is 1, degree of the bottom is 2. So since the degree of the bottom is bigger, we're going to use that first rule that we had on the last slide. And the horizontal asymptote will just be y equals 0. And then the last thing is intercepts. So to find x and y intercepts, you just have to let the other variable be 0. So to find an x-intercept, we have to let the function be 0. So the only time a function or a fraction can be 0 is if you have 0 on top. And when we set the top equal to 0, we get negative 2/3 for x, and then we plugged in 0 for y. And then to find a y-intercept, we replace x with 0. So if we just replace all of our x's with 0, we're going to get 2 over 6, which reduces to 1/3.